Okay, good evening. This is Professor David J. De Los Reyes. It's January 16, 2023. The time is around 8:25 p.m. Okay, I've got a new topic for tonight. It will now be Advanced Mathematics lesson number, I think this is now number 5. Advanced Mathematics lesson number 5. We are on the topic Advanced Mathematics. This is now lesson number 5, and I will now be giving example number 4. It's an evaluation problem of a higher order derivative which are non-homogeneous. Okay. Okay, let's try to bring up the example. This will now be example number 4. I presented 3 solutions already for a higher order non-homogeneous differential equation. So for tonight, it will be another variation of a problem that is a third order non-homogeneous differential equation. Non-homogeneous meaning the right hand side is not equal to 0. It is, for tonight, it's a combination of an algebraic function and a trigonometric function. Okay, I will try to give the problem. D cubed y over dx cubed plus d square y over dx square equal to x square plus sine of 2x. The problem is asking for the general solution. It says for this one, this is y triple prime plus y double prime is equal to x square plus sine of 2x. If you try to notice it, the right hand side is now a combination of an algebraic function and a trigonometric function. Okay, I think the last time around, the right hand side is an exponential function. And the other examples are the right hand side is a plain sine function. So for tonight, it will now be a combination of an algebraic function in a sine function. The problem is asking for the general solution. This is Advanced Mathematics lesson number 5. Okay, let's proceed with the solution. First part of the solution is the complementary solution. Complementary, this is an E, this is an E. It's not an I, right? It is complementary solution. Complementary solution is actually represented by y sub c equal to k a to the mx. This subscript here refers to complementary. Y sub c. We read this in engineering. Okay, particularly if we are on differential equation, y sub c is equal to k e raised to mx. Okay, let's try to take the first derivative. Y prime of c, meaning the first derivative of y with respect to x, is equal to km e to the mx. Should be k. The differential of m is actually m times 1 or just simply m. So the product of k times m is km. So y prime c is actually km e to the mx. Okay. We've been always doing this one under the complementary solution, so you should now be familiar with this one. Y double prime of c equal to, take again the derivative of the first derivative. So it will be km times m, this will now be km squared times e to the mx. We keep repeating, taking the differential of the exponent, which is m in the product of m and x, and the differential is just actually m times 1. So this will just be km times m again. So this will be km squared e to the mx. Y triple prime. Y triple prime of c is actually the derivative of the second derivative. So it will now be km cubed times e to the mx. It will just be simply km squared times m. So it will now be km cubed times e to the mx. Okay? We will take the value of the third derivative and we will take the value of the second derivative. We put back here. Okay? So I place it here, substituting and equate to 0. Substituting and equating to 0. The third derivative is km cubed e to the mx. Second derivative is km squared e to the mx. Okay, for the complementary solution, we equate the right hand side to be 0. At the time we are taking the complementary solution, and after the substitution, we equate the right hand side to be 0. Okay, there's a common factor k e to the mx. So if we try to multiply all the terms by the reciprocal of that, 1 over k e to the mx, okay, try to expand. This k here cancel with this e to the mx cancel with this. So after the multiplication on the first part, what remains is just an n cube. Second part, this k here cancel with this, e to the mx cancel with this. What comes out for the second term on the left will just be simply an m squared. And this should be equal to 0 times 1 over k e to the mx is still 0. Under the complementary solution, we term this one, or we call this one as the characteristic equation. Characteristic equation is the equation that gives us the roots of the required complementary solution. So by using our knowledge of factoring, n cubed can be written as the product of m times m, right? That's n cubed. Okay, and the product of m squared will be, it seems for the meantime this is 0, right? Right? So what will come out? M times m is actually m squared times 1, that's m squared. But for the matter to be more, what you call this, clearer, we put this one to be minus 0. Doesn't matter, right? So the sum of m cubed plus m squared can be written as the quantity, the product of three quantities, that is m minus 0, m minus 0 times the quantity m plus 1, and this should be equal to 0. And under the rules of algebra, to find the possible roots, equate each factor to 0. So m1 now will be 0 if we take this one, m2 will be 0 taking the second one, and m3. These are subscripts, okay? M sub 1, M sub 2, M sub 3. So the third root will be M sub 3 equal to, after equating it to 0, this will be placed on the negative right side. So M sub 3 is actually negative 1. So the three possible roots of the required solution will be M1 equal to 0, M2 equal to 0, and M3 equal to negative 1. And if we try to recall the formula and how to take the complementary solution, it is this. Okay. This is to be multiplied by e to the 0. Okay. I just expedite a little bit. But e to the 0 is 1. So, or this, that will just be simply times 1. So 1 times the quantity k1 plus k2x will just be simply the sum of k1 plus k2x plus the required complementary solution for the third root will be a third constant of integration k3 e raised to negative 1 times x is just negative x. So this is now the complementary solution. This is y sub c. Okay. The first one falls under case number 1, in which the roots are equal and they are real. K1 plus K2x times e to the common root, which is 0 times x, it will become 1. So this will just be simply K1 plus K2x plus K3 e to the negative x. Oh, not so much on the complementary solution. Okay, let's proceed with the particular solution. This is the harder part of the solution. For the particular solution, okay, for this problem now, I let y sub p, meaning particular solution, equal to ex squared plus bx cubed plus cx to the fourth. This part of the solution will take charge of the algebraic function. Okay? You can choose any, what you call this, algebraic solution you want, okay? But if after checking it, it doesn't conform with the given right-hand side, you're wrong, right? I am telling it for tonight that the equivalent particular solution of this x square will be a sum of four algebraic functions, that is ex squared plus bx cubed plus cx to the fourth. Okay? And for the cosine function, it is the combination of these two terms here. It is a combination of a sine function and a cosine function. Why there is a cosine function? Okay, there is a sine function, and if you keep repeating taking the derivative, there come a time that there will be a cosine, right? So I think the particular solution for this part here, there should be a sine function and a cosine function, okay? So we place here another constant d, which we do not know at the meantime, sine of 2x, we're just following this, plus another constant a, cosine of 2x. So this part of the solution, particular solution, will handle this one, the trigonometric function. So if you try to notice the particular solution, it's a little bit complicated compared to the complementary solution. Okay, assuming that our particular solution is correct, okay, let's proceed with the continuation of the solution. This is just an assumption. So this is where you will bring out your intellect, okay, on the particular solution. You could choose any particular solution you want, but if after checking it, it will not conform with the given right-hand side, you are wrong. So it seems this is a trial and error. Since I am the one teaching, I am saying that the particular solution of this x squared here will be a sum of three terms here, which is an unknown constant a times x squared, plus an unknown constant b times x cubed, plus an unknown constant c times x to the fourth. Okay? Okay, let's try to take the first derivative of the particular solution. Yp prime equal to the derivative of this, 2ax, our formula. The derivative of this will be 3bx squared, so this is 3bx squared, still power formula. This one here will be 4cx cubed, 4cx cubed. Okay? For the next term, d sine of 2x, it will be d times the derivative of sine. The derivative of sine is cosine, right? So this is cosine now. But the derivative of the angle will be 2 times 1, or actually 2. So d times 2 will be 2d now, right? This 2 here emanates from the so-called derivative of the angle, right? So this is plus 2d cosine of 2x. The derivative of cosine is a negative sign, so this will now be negative e sine of 2x times the derivative of the angle. The derivative of the angle is again 2, so this is 2 times e, right? This negative sign emanates from the derivative of the cosine. It's negative cosine sign, right? So this is now negative. This 2 here emanates from the so-called derivative of the angle. The derivative of 2x is just 2. So the coefficient of the sine of 2x will be negative 2e. Okay, that's the first derivative. Oh, that's just basic differentiation, right? Taking the second derivative. Take the derivative of the first derivative. What comes out is y double prime of p. Okay, differentiate again this one. The derivative of 2ax, 2a is constant, so it will be 2a times 1, or just simply 2a. The derivative of 3bx squared, 3b is constant. This falls under power formula. 3b times 2 will be 6b. X raised to 2 minus 1, or just simply x. Next one will be 4c is constant, times 3, that will be 12c. Power formula, this will be an x squared. Right? You can follow it. This one here, okay, it keeps changing from cosine to sine, right? That's why the particular solution comprises of a sine and cosine. That's why we don't neglect this cosine here. There should be a cosine thing. The derivative of cosine of 2x will be negative sine of 2x, right? So this is negative sine of 2x. Okay? This is now negative because it's negative. I place the sign now. The derivative of the angle is 2. So 2 times d will be negative 4d sine of 2x. This one here, it will just be simply the derivative of sine is plus cosine, right? So the sign will still be negative because a plus and a minus will still be minus. But the derivative of the angle is 2, so 2 times a will be negative 4a cosine of 2x. Okay? Just be accurate with the sign because if you miss one sign, you are wrong, right? Okay, I will check my camera. Okay, let's try to take the third derivative. The third derivative of the particular solution is just the derivative of the second derivative. Or take again the derivative of this one. The derivative of 2a will be 0. So I didn't place 0 there. The derivative of 6bx, it will be 6b times 1 or just simply 6b. The derivative of 12cx squared, 12c is constant. This falls under power formula. So 12c times 2 will be 24c times x, power formula. And for this, the derivative of sine will still be a plus cosine, so a plus and a minus will still be minus, and this will become cosine, but the derivative of the angle is 2, so minus 4d times 2, this will now be negative 8d cosine of 2x. Right? The last part, the derivative of cosine is negative sine. Negative, negative, this will now be plus. Okay? The derivative of the angle is 2. So 4a times 2, it will now become 8a sine of x. But this is now plus. Because the derivative of cosine is minus, and this is preceded by minus, so this will now become plus. So y triple prime is actually 6b plus 24cx minus 8d cosine of 2x plus 8a sine of 2x. Okay? We got a problem here. We do not know the value of A, we do not know the value of B, C, D, and E. And using our knowledge of the so-called equating coefficient of like terms, like in the so-called partial fraction under integral calculus. So I place it here. Okay, substituting. Meaning substituting, we will take the third derivative and the second derivative. We place back in the original problem. Okay, so it is this. Okay, this is the first derivative, third derivative. This is the second derivative. Okay, and this should be equal to the right hand side. The right hand side is the sum of x squared plus sine of 2x. Then to compute for the values of a, b, c, d, and e, we do not know the value of a, we do not know the value of b, c, d, and e, right? And equating coefficient of like terms, like in the principle of the solution of the unknown coefficients under partial fraction. Equating coefficient of like terms, okay? We will start with x squared. The highest power of x for both the left and right is actually second. So for x squared, okay, mm, 12cx squared. 12cx. This is x squared. Sorry for this one. This is square. Syntax error, right? We are just following this, right? We start with x squared. For the left hand side, the coefficient of x squared will be 12c. So this is 12c. And no more x squared, right? Except this one. And for the right hand side, the coefficient of the term that carries the variable thing x squared is actually, this is actually 1 times x squared, right? Okay? So the coefficient of x squared on the right hand side will be equal to 1. Therefore, C now will be 112. Okay, let's proceed with x to the first power. Uh, what are the terms that comprises the x term on the right hand side? It is this part here. So this is minus 24c. This is cosine function, sine function. Okay. This is 6bx. It contains an x. So this is plus 6b. Right? Then no more x. On the right hand side, we don't have a term with an x, right? We can say anything. It's only x is here and sine of 2x. There is no x. Actually, there is an x over here. Plus 0 times x to the first. Actually, because 0 times x to the first is 0. So on the right hand side, considering x to the first, the coefficient of x to the first is 0. So I place it here 0. Okay? 24c plus 6b equal to 0. And we know now c, right? So we could compute for b. So if we get the value c to be 112, we place it here. b now will be negative 1/3. Okay? We'll go for the term x to the 0. All the terms with the component x to the 0, or this is just the pure constant, PC, pure constant. The pure constant term on the left is 6b. Okay? Is it 6b? Yeah, this is 6b. Right? 6b. Pure constant term, this is an x term, cosine, this is sine, plus 2a. Plus 2a. 6b plus 2a. This is, right? This is an x term, x squared term, sine function, cosine function. Then on the right hand side, there is no pure constant term, but we could write it as simply plus the coefficient 0 times x to the 0. Okay, we can find anything because x to the 0 times 0 is just 0. So actually, if we compare, if we try to equate x to the 0 for both the left and right, what comes out will be 6b plus 2a. And for the right hand side, it should be 0. So this is equal to 0. But we now know b, right? So we could compute for a, and a is actually 1. For the sine function, on the left hand side, the coefficient of sine function is 8a. Right? What's the other sine function? Minus 4d. Minus 4d. This is a sine function, right? Equal to, on the right hand side, we got a sine function. It is sine of 2x. This is actually times 1, right? So actually the coefficient of sine of 2x is 1. So 8e minus 4d should be equal to 1. It is not 0 because we got a sine function on the right? And the coefficient is actually 1. So 8e minus 4d equal to 1. We call this equation number 9. For the meantime, we do not know d, we do not know e. Okay, so there is an equation that contains two unknowns. We call it equation number 1. For the cosine function, on the left, it will be minus 8d. This is a cosine function, right? The coefficient is minus 8d. Where's the other cosine function? It is this one. This cosine function, what's the coefficient? It is 4a. But this is negative, right? So this is minus 4a, and this should be equal to 0. And actually, we could bring out now the relation of e and d using the cosine function, in which e, if we try to simplify, will be negative 2d. And if we call this equation number 2, okay, this is now the part of an algebra. We got two simultaneous linear equations and two unknowns. So to solve for the problem, we use it the so-called solution by substitution. we will let E equal to minus 2D, we put back on equation number 1. Okay, then we can compute for D. I then place the exact, what you call the substitution. But if we try to compute for the value of D, if we try to substitute minus 2D on equation number 1, D now will be negative 120. Okay? So E now will be negative 2 times negative 120, and this is 110. So we now know the value of A, B, C, D in A. B, C, D, and E. So to bring up now the particular solution, we will follow this one. Ex squared, that will be, A is actually 1, that will be an x squared, okay, plus B, but what is B? Negative 1/3 x cubed, we're following this, plus the value C. What is C? It is 112, okay, times x to the 4th, plus the value D. The value of D is actually negative 120, so this negative 120, we are following this, sine of 2x, plus the value of E, which is 110, okay, cosine of 2x. So this is the particular solution. X squared minus 1/3 x cubed plus 1/12 x to the 4th minus 1/20 sine of 2x plus 1/10 cosine of 2x. So the total general solution now, as always, it's the sum of the complementary solution and the particular solution. Okay? So if I will write the complementary solution, this is the complementary solution. And for the particular solution, it is an x squared minus 1/3 x cubed plus 1/12 x to the 4th minus 120 sine of 2x plus 110 cosine of 2x. This is now the total general solution. Okay? To check the validity of our answer, okay, take the third derivative of this one, then take again the second derivative, then try to take the sum. After taking the sum, okay, or after the simplification, what will come out, supposed to be on the right hand side, will be an x squared plus sine of 2x. I didn't show you this one now, but you could do it yourself, okay? That's the proper way on how to check the validity of our answer. This is our final answer for the general solution. Okay, that's it, guys. It's a combination of an algebraic and a sine function. Okay, after taking the complementary, we assume a particular solution. Okay, then try to compute for the unknown constants or unknown coefficients of your assumed particular solution. So after the computation of the unknown coefficients of the particular solution, you can bring out now the particular solution. So to bring out the total general solution, it will just be simply the complementary plus the particular. That's it, guys. So for those people or students, okay, who are taking advanced mathematics, this is for you guys. If you like my lecture, please click like. And if you want to subscribe, you can subscribe. My channel is actually at youtube.com/@Prof. David J. De Los Reyes. And if you want to share it, please click share. Good evening, Los Angeles.